So today we are going to discuss about vector equation of a line. So when we discuss about this, we need to have a defined vector. Suppose in this case from the origin, and that vector is called A, and this point is called capital A point. Now we are going to define another vector which is D, right, in this direction. So I'm going to translate that into here. So that D vector is going here. So this is the line we are discussing. This is the line we are discussing. So now from this point to the line, right? So from this point to the line, I'm going to have a vector, another vector. So suppose this point is R in general. So this is R vector. Now this AR we can write, this AR vector we can write lambda times D vector. So where in this case lambda is greater than 1. Now from the vector triangle, so you can write OR, which is R vector, to be, this is going to be OR vector. So R vector to be A plus lambda times D vector. So this is A, lambda D is going to be this AR. Now this lambda is called parameter. This is the parameter now. So that means this R is a function of lambda. So the meaning of this one would be in this way. So when lambda is equal to lambda, so you're talking about this point, and maybe lambda is equal to lambda 1, you're talking about this point. So that means you're talking about this vector, right? So this is when lambda is equal to lambda 1. So likewise, when you change the lambda, so you are literally changing this point. So now when you change the lambda, you can see we are changing all of these vectors which is defined from the origin, and then we are looking at a line. So we define this line through this setup. So this is called the vector line. So we can say vector line is defined by this R of lambda is equal to A plus lambda D. So from this equation we define this line. So this is nothing but this line. So when you change lambdas, you're talking about different points on the line, right? So suppose this point, for example, so when lambda is equal to lambda 2, so you can find this vector where you are looking at this coordinate or this point on this line. So this is how we define a vector line. Okay. So now moving forward, we can think about this. So think about a system like this. So this is the vector line, right? And this is my origin O. So now from here to this point, where capital A point, I'm going to have a vector which is A, and there is a vector parallel to this line, and I would say this is D. That is D vector parallel to this line. So this is the line we are talking about. Now in general, you can think about a vector which is R vector. I would say lambda, right? So A plus lambda D. So lambda D means AR vector, right? So this is nothing but AR vector. Okay, now this is very clear. So this is a vector. Now let's think about this. So you need to find the shortest distance from this point to this line. So that means we need to find the shortest distance. So that would be this. So this is the shortest distance. I would say h, right? So this is a scalar. So this is the shortest distance, right? So now shortest distance. So shortest distance is D, right? So not D. In this case, I took this one as h. So shortest distance h is what we need to find. So what would be the strategy we are going to use? So now logically think about this. So when lambda is equal to lambda, so you are going to recover this point. So that means when you are changing lambda, suppose lambda is equal to lambda 1 here. So lambda is equal to lambda 2. We are talking about this point. So lambda is equal to lambda 0. Suppose we are talking about this point. So when lambda is equal to lambda 0, we are talking about a vector which is O. Suppose this is like maybe x, right? OX, right? So that means OX vector is R of lambda is equal to lambda 0, or you can say R of lambda 0 if you want, right? It's pretty easy. Now, R of lambda 0 is this vector. So now how do we know precisely whether this vector is perpendicular to this vector, right? So if you can find this lambda 0 where these two vectors are perpendicular to each other, so then we can find this, right? So let's do that. Now in that process, what we can do, now we know the dot product, right? So dot operator is what we are going to use. So d vector, we are going to dot with R of lambda 0. So if you do that, and the output should be 0 if they are perpendicular to each other. So from here, what we can do, right? So from here, what we can do, now this dot product gives a scalar, right? So this gives a scalar. So from here, we get a lambda 0 value. So we get a value here, right? Suppose this value is k, right? Suppose this value is k. So now k is a known value now. So this is a known value, right? We'll discuss the question later. Now, if k is a known value, now we need to find that h, right? So h is nothing but now, right? R of lambda 0, that is that vector, and the magnitude of that one. So in this case, we can say R of this vector is, this value is k, and magnitude. So this is a known thing, and you get the magnitude, right? So that's how we can find this h value. So now how do you get the magnitude here? So that we will discuss in a minute. So suppose you have a p vector, right? So we're talking about the magnitude. Okay, suppose you have a p vector, right? So p vector is written as, in general, p vector magnitude with p hat, right? So this is the definition of a vector, right? So this is the definition of a vector. Okay, so it will be pretty clear. So now, if you need to find this guy, so what we are going to do, we are going to use the dot product between p and p. So this is going to be p vector and p vector magnitudes. Then p vector magnitude dot p vector p hat dot p hat, unit vectors. Right? So we know that this is a unit vector. All good. So now when you do the dot product between unit vectors, so that is going to be 1, right? So from here you get p vector magnitude squared, right? P vector magnitude squared is going to be p vector dot d vector. So from here you get p vector magnitude to be p vector dot with p vector and the square root. So this is how we find a magnitude. So in the previous question, so h was r vector of k magnitude. So this you can find r vector, which is the new parameter. So this is a known value, dot with r vector when lambda is equal to k and the magnitude. So from here you get the answer. So this is how you find the shortest distance from a point to a vector line. Okay, good. So now let's think about an example. think about a vector is I plus 2j minus k, right? Then think about d vector to be 2i minus j plus k, right? So we need to find the shortest distance from origin, right? 0, 0, 0, right? So this is origin. So this is a point, and this is our arbitrary point, and this is r of lambda now, right? So a vector is defined in this way, and d vector is defined in this way. So the final goal is to find this head, which is a scalar, right? So this is the shortest distance from this point to this line. Now, let's define this r of lambda with the given details. So r of lambda is now a plus lambda here. So it's going to be I plus 2j minus k plus lambda times d. So d would be 2i minus j plus k. Okay. So that's all good. Now this d vector is known, right? So d is this. So that d vector is known. Now what we can do to find this guy, yeah, so we need to find a specific lambda value, because this lambda is equal to lambda 0 is specific value. This is a specific value when these two are perpendicular to each other. So what we are going to do, r of lambda, right? Actually, you should get lambda 0 because that's a specific value, dotted with d, right? Should be equal to 0. So now this is the operation we are going to do. Now r of lambda 0, so that's going to be, okay, so that's going to be I plus 2j minus k, right, plus lambda 0, then this is going to be 2i minus j plus k, right? So this whole thing dotted with d is going to be this guy. So it's going to be 2i minus j plus k, and that should be 0. So now what we need to do next is to evaluate this. Okay, so now how we do that, right? So now when you are dotting, I only dot, right? So what I'm going to do, so I'm going to have i's and j's and k's from here, and then from here, and then that will be dotted with this guy, yeah? So what we can do from there, so I'm going to club all the I components here. So it's going to be 2 lambda 0, and that is I plus, so j component, so it's going to be 2 minus lambda 0, and that is j plus k component, it's going to be minus 1, so it's going to be lambda 0, right? And that is k, that I'm going to dot with, these I'm going to dot with this guy. So it's going to be 2i minus j plus k, and that should be 0. So now when you are dotting, I only works, right? ij is going to be 0, why? Because it's perpendicular. So now what we are going to do, 2 times 1 plus 2 lambda 0 plus then jj. So it's going to be, now there you have minus, so it's going to be minus 2 minus lambda 0, and then kk, then that's 1, so it's going to be plus minus 1 plus lambda 0 dot with 1, right? So, and that's going to be 0. So now it's just a matter of finding lambda 0. So from here you get 4 lambda 0, right? So okay, I'm going to do it. 2 plus 4 lambda 0, then here you get minus 2 plus lambda 0, then you get minus 1 plus lambda 0, and that is going to be 0, right? So now you can see 2 lambda 0, there's going to be 6 lambda 0 now. Then plus 2 goes with minus 2, so you have minus 1 here, move to the side, so it's going to be 1. Okay, now let's see. So 4, 5, 6, 2 gone, and then minus 1. Okay, good. So now from here you get lambda 0 to be 1 divided by 6, correct? So we got that. right? Good. So now that value is substituted here, right? So that value is substituted here. So now what we can do here, so that r of lambda 0, right, you can find by substituting 1 divided by 6 here, right? So that would be I plus 2j minus k, right, plus 1 divided by 6, and you have to do this. A little bit of pain, but 2i minus j plus k. Good. So now we will simplify this a little bit. So if I do that, I get here 1 divided by 3 and I. So 1 divided by 3. So it's going to be 4 divided by 3i. Yep. So this is going to be 1 divided by 6. Right. So it's going to be 2 here. So it's going to be 1 divided by 6. So it's going to be 12. So it's going to be 11. So 11j divided by 6. Good. Now this is going to be 1 divided by 6. This is going to be just that. So when you have the common denominator, it's going to be 6 here. So it's going to be minus 5k divided by 6. Right, great. So we get r of lambda 0 to be this. Now what is my h now? What is my h? So this h is nothing but r of lambda 0 magnitude of that one. Okay, so that's what we are going to look at. So now moving forward, what we can do, we can get the magnitude of this one, right? So it's going to be r of lambda 0, right? So dot r of lambda 0 is what we are going to do now, right? So before we take the square root. So if you do that, so what you're going to get is the square of these terms, right? So I'm not going to simplify, but I'm going to write 4 divided by 3 squared plus 11 divided by 6 squared. Then doesn't matter, minus, it's going to be 5 divided by 6 squared, right? So now r of lambda 0, which is in our case 1 divided by 6, magnitude is nothing but the square of this guy, yeah? So it's going to be 4 divided by 3 square plus 11 divided by 6 square plus 5 divided by 6 square root. So this is a length, so you get this as unit. So this is the final answer. So this is how we have to understand, vector lines.